Okay, we are looking at 5.1 and 5.2, and this deals with systems of equations. So this will be a review. So we have to solve systems of equations. Okay, so there are different ways that you can solve. So one of them could be graphing. When you graph them, you're looking for the point of intersection. Another way is by using substitution. And then another way is the addition method. And then matrix, but we are not going to do matrix right now. We're going to do that later. So whenever you do your assignment for this, I'm going to ask that you do it using one of these methods, particularly these two, substitution and the addition method, so that we are not going straight into matrix. We are sticking with these two, okay? Okay, something to remember about the number of solutions. If we have exactly one solution, xy, that means lines intersect. And so our solution would be written as an xy. We can have no solution. So we would write that as 0 with a slash. And that means we have parallel lines. To have parallel lines, you would have equal slopes. Equal slope, equal slopes. And then the last one is infinitely many solutions. And this one will be written as, we used to write it as infinity or all real numbers whenever it's just an equation that we're solving for a variable. But when we're solving and we have a system of equations, we are going to write it like this. xy such that you do your first equation, and then you write your equation 1. And then you write or xy given equation 2. I think that's how that's written. Yep. And to have infinitely many solutions, that means that the two lines are identical. Okay, we also have real world application. And this is used in the real world, mainly in business, whenever you're figuring out cost and revenue. Go ahead and get off your computer, please. So when we have revenue, here we go. Is called R of X. And this represents price per unit sold. This intersects the amount that's coming in that you're charging someone. So this is found by doing the cost multiplied by however many number of items were sold. So I would say number of items. And then cost is like your fixed costs. We'll say you own a business. Your fixed costs would come from operating the business on the day-to-day, keeping your doors open, paying your employees. So this is what is going out. This is found C of X equals the fixed cost plus the cost per unit to make. Revenue is the cost as in how much you're selling it for, selling price, times how many you sold. And then the cost is found by doing your fixed cost plus your cost per unit to make it. And to be in a good business where you're actually making money, you want to first break even. Do y'all know what break even means? Okay. So break even is when your costs and your revenue are equal. Right. No loss, no profit. So you want to get to a break even point, but then after you get to that break even point, you want to start making more money than it's costing you to run your business. So you want to start making a profit. And that's called your, and this comes down to, see how we have two equations? That's a system of equations. To figure out our break even point, we would see what amount of items would it make it where we don't have a loss and we don't have a profit. Okay, so let's look at our handout where we have some examples. So for number 1, determine if the ordered pair is a solution to the system. To determine if it is a solution, you would do substitution. You would substitute in the x and y and make sure it truly is equal on both equations. So we have x plus 3y equals 11. So we plug in x equals 2 and y equals 3. So it would be 2 plus 3 times 3 equals 11. And make sure that is true. So it'd be 2 plus 9. 2 plus 9 does equal 11, so that is true. And then we would try the second equation out. X minus 5y equals negative 13. So we would do x is 2 minus 5 times 3 equals negative 13. We want to see if that's true. 5 times 3 is 15, so we do 2 minus 15 equals negative 13. And that is true. So determine if it's a solution. 2, 3 is a solution to the system. Okay, let's look at number 2. Solve by substitution. So we have x plus y equals 4 and y equals 3x. So when we do substitution, we usually do it whenever you have one of the variables already solved out. So it's this one. So for y, we are going to plug in the 3x. So it's going to be x plus 3x equals 4. Because it was x plus y, I'm replacing that y with 3x. So then x plus 3x is 4x equals 4. Then we divide by 4, and x equals 1. But to have a solution to a system, you need to have an x and a y. We only have an x, so in order to get the y, let's use this equation again. You could use the other one if you want, but this one's already solved. I'm going to do y equals 3x. I'm going to substitute in this 1 for the x. So y equals 3 times 1, which just equals 3. So then my solution is 1, 3. The solution set. 1, 3. So we just have one solution there. Gives us more space, but we already used it. We already solved it. Okay, let's go to the next one. Solve the system. So we have both of these equations, and they're both in standard form. So we want to use the addition method. And the way we do this is we want to be able to cancel out either the x variable or the y variable. Right now we have a 3 and a 2. We have a negative 4 and a 3. So we want them to be the exact same number, just opposite. So like 3 and negative 3 would be perfect. So we just need to figure out how to change it so that we can cancel something out. There's more than one way to do it. We could focus on the x's or focus on the y's. Does anybody remember this? Okay, what do you want to multiply by? Okay, so what's your goal? To have 6 and negative 6, that's right. So multiply this by 2 all the way through, and this one by negative 3 all the way through. So then that would be 6x, negative 8x, y, yes, equals 22. And then the negative 3 times 2 would be negative 6x. And that's our goal. We want these to be opposites so that they cancel out, equals 0x. Negative 3 times 3x, 3y, negative 9y. And then negative 3 times a negative 4, making that a positive 12. So now we can add them up. This becomes 0x. So I no longer have an x. But now I have negative 8y and a negative 9y. Making that a negative 17y equals 22 plus 12, because we're adding this, is 34. And then divide by a negative 17. equals -2. So once we have the y value, then we can substitute that y value in and solve for x. Substitute and solve for x. It doesn't matter which equation you choose, either one, you'll still be able to solve it out. So if we use the top one, we're going to plug in a -2 for the y. So it'd be 3x minus 4 times a -2 equals 11. So 3x plus 8 is 11. So -8. 3x equals 3. Divided by 3. X equals 1. So we have an x and a y value. So our solution set is x, y. So 1, -2. Okay, number 4A, solve the system. So we have these set up in a way that it would be easiest to do substitution because this is already solved. So we can put in this for the x value. So instead of saying x plus 2y, we'd say 9 minus 2y, which is your x, plus 2y equals 13. Well, the minus 2y plus 2y is 0. So we have 9 equals 13, and that is not true. So we have a no solution. Or the empty set. It can also be written like this, where you have the braces and nothing in there. It's an empty set. For B, we have y equals 3x minus 5, and then 21x minus 35 equals 7y. We have this already solved for y, so we're going to input this in for y. That'd be the easiest method. So this again is substitution. So 21x minus 35 equals 7, and then parentheses 3x minus 5, because I'm inputting that y right here. So that would be distribution, 21x minus 35 equals 21x minus 35. What do you notice about that? It's the exact same thing. We could simplify and get -35 equals -35. So that means it's infinitely many solutions. So we are going to write it as the solution set of x, y, such that y equals 3x minus 5, or, remember equation 1, or xy such that equation 2. So this is our way of saying it's infinitely many solutions. Okay, and our last example is a business example. A company that manufactures small canoes has a fixed cost of $18,000. Additionally, it costs $20 to produce each canoe. The selling price is $80 per canoe. Write the cost function. So C of X is your cost function. And that's found, if we look back at our notes, it's our fixed costs plus the price per unit. Fixed costs plus the cost per unit to make. So that would be listed as 18,000 plus $20 times X. Okay, the next page gives us a spot to do our revenue function, R of X. How much does each canoe cost? Or no, sell for? How much does it sell for? It'd be 80X. And to break even, we would set the cost and the revenue equal to each other because we want the cost to equal the revenue. So we don't have a loss and we don't have a profit. So C of X equals R of X. So that'd be 18,000 plus 20X equals 80X. And we solve that out. And X represents the number of canoes. Because it's 80 times however many canoes. And then 18 plus 20 times however many canoes. So what does this mean? What do I need to write on what this means? Mm-hmm. When the company sells 300 canoes, it will break even. It'll break even with cost and revenue. And to figure out how much revenue that is, we'd want to do 300 times 80. So at 24,000. Okay, let's look at systems of equations with three variables. So sometimes you have more than just two variables. So in this case, this one has x, y, and z. So we want to see if the triple 2, -1, and 3 is a solution. So we need to plug those into each of our equations. Here's our first equation, second equation, third equation. We're going to plug in an x, a y, and a z. So on the first one, we have x plus y plus z equals 4. So it'd be 2 plus a -1 plus 3. One plus 3 equals 4. So it works on the first equation. Go ahead and try your other equations to see if it works. Okay, so it's on the very last one that it doesn't work because it's 2 equals -1. So it's not a solution. Okay, so let's do some more complicated ones with the three equations and then 3 variables. So if we look over at our example, this one says add the 2 variables to eliminate. Hello? No? Okay, so it says add the 2 first to eliminate one of the variables. Multiply the first equation by 2 and add it to the third to eliminate z again. Solve the system of equations in the 2 variables. Multiply the second. It seems like a lot, right? Do y'all remember doing this? It's been a while, though. Okay, so what could we do? How could we solve it out? What do you think? So we need to solve one of the equations. Okay, so which one do we want to solve for? We want to solve for x or y? Solve for x on which equation? The second one. Okay. So x plus 2y minus z equals -1. So we're going to solve for x minus 2y plus z minus 2y plus z. So this would be x equals -2y plus z minus 1. Okay. Now what do we need to do? Put this into the first right here. Okay. So 4 times the -2y plus z minus 1 minus y plus 2z equals 11. -8y plus 4z minus 4 minus y plus 2z equals 11. So that would be -9y plus 6z. And then I need to move that 4 over, so plus 4. So equals 15. Okay. Now what? To do the same thing to the last equation? What do I want to solve it for? Or do I want to substitute in? Substitute in? Okay. So I'm going to substitute in here. So 2 times the -2y plus z minus 1 plus 2y minus 3z equals -1. Okay, so what do y'all think about that? Is that what y'all got? Same thing? Okay. So now that I have these two guys, what do I need to do? Yeah. We want to get rid of one of the variables, so the easiest way would be to multiply this times 6, because then you'd have a 6 and a negative 6. So we still have the negative 9y plus 6z equals 15. But then our second equation, the new one, is negative 12y minus 6z equals positive 6. Add these together. Negative 21y equals 21. Divide by negative 21. So y equals negative 1. Okay, so we have one variable done. Now we need to find x and z. Where could we plug in y so we can get the x or z? We can pick either one of these. Which one would be easier? Yeah, the bottom one. So negative 2 times the negative 1 minus z equals 1. Because you're using the negative 2y. So it's positive 2 minus z equals 1. Minus 2 minus 2. Negative z equals negative 1. Change the sign on both of them. Z equals 1. Okay, so we have y equals negative 2, z equals 1. Now we just need to get x. Into what? It's hard to hear you. Okay. So which equation do we want to use? Does it matter? Oh, this one, right? Yeah. Okay, good. Forgot about that one. So I plugged in y and z. So x equals negative times negative is positive. Well, 1 minus 1 is going to cancel. So x equals 2. So then our solution set is x, y, z. So 2, negative 1, 1. Okay, so that is all we're going to do on notes. Your assignment will be posted tomorrow, so y'all can do it in class tomorrow.